The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, just know you will be able to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Understanding the True Cloud and Kubernetes Costs of SaaS Tenants at Relativity. Our speakers today are Corey Wagehoft, who is the lead systems engineer at Relativity, and Ravi Lachman, who is a developer advocate at Harness. Gentlemen, thank you so much for joining me today. Really appreciate it.
Yeah, thanks for having us, Charlene.
Thank you.
Awesome. Well, Ravi, I think you are going to kick things off, so I'm going to put myself on mute, take myself off camera, and let you get right to your presentation.
Absolutely. Well, very excited for everyone to be here today. Lots of great things to learn from Corey and myself today. So a little bit about ourselves. So Corey, he's a lead system engineer at Relativity, really wise person. He's going to walk you through some of the challenges and ebbs and flows that him and his team has went through in Relativity. And I'm Ravi Lachman. I'm a developer advocate here at Harness. So what are we going to be talking about today? We're going to be talking about understanding the true cloud in Kubernetes. So what does that actually mean? Well, your infrastructure has to run somewhere. There's no such thing as a free Kubernetes. It's open source, but it does take a lot of expertise. It does take infrastructure. And this is what Corey's going to be walking us through today. And also the cost of SaaS tenants at Relativity. So one thing when looking at a software as a service company, we're here to serve our customers, but really it's sometimes very difficult to hammer down what are the costs for additional customers, what's the cost per customer. There's a lot of sunk costs, there's a lot of innovation costs. How do we go about actually tracking that and making sure we're optimizing that? And then I'll take it over for doing a cloud cost visibility demo. So at Harness, we have a new product we launched called Continuous Efficiency. And then we're going to open it up for Q&A. So if you have any questions, feel free to ask Corey and I. And with that, I'm going to pass it back to Corey to talk a little bit about Relativity and where their industry sits. So Corey, I'll give it right back to you.
And were you able to switch?
Yeah, gotcha.
Thank you very much, Ravi. Appreciate it. Switch to the presentation here. So yeah, like Ravi said, hi everyone. My name is Corey Wagehoft. I've been a lead system engineer here at Relativity for almost 3 years, and my primary focus is on our global Kubernetes architecture. At Relativity, we make software to help users organize data, discover the truth, and act on it. Our platform is used by thousands of organizations around the world to manage large volumes of data and quickly identify issues during litigation and compliance operations at with RelativityOne. Relativity has over 180,000 users in 40 countries, from organizations including the US Department of Justice, more than 70 of the Fortune 100 companies, and 198 of the AM Law 200. So today we're going to talk first about a little bit of Kubernetes. Let's start with some of the benefits of Kubernetes. Many people are familiar with Kubernetes already, will know these things, but here are just a few of the benefits. Some of them is high availability. You get easy horizontal auto scaling and portability because you're using containers between environments. All of the technical reasons out here are really great, but at the end of the day, these need to translate to business value. Obviously, some of the things I said, they have business value already, but let's go a little bit deeper. Some of the key things you can do to help with this is by using managed Kubernetes instances, which can help reduce operational costs. Definitely leverage auto scaling of your nodes. You don't want to necessarily keep paying for all this compute that you're not using, so maximize that by leveraging auto scaling. And also with higher compute density, that's a great thing with Kubernetes. Before Kubernetes, you were on VMs, and you traditionally didn't want to run a VM at 90% CPU capability in case you had bursting problems. With Kubernetes, that's completely opposite. We want to maximize the cost per hour in the cloud by leveraging and keeping the density really high on these nodes, so that you are you're getting everything that you pay for, and you do want to run these at high utilization. Something you need to consider about when moving to Kubernetes is how it's going to affect the COGS in your organization, or cost of goods sold. While I don't hold an MBA, as an engineer, it's really important to understand the way their workloads affect the COGS of a business and their profit margins. With traditional cloud resources, it's fairly easy to track the cost of your VMs through cloud management billing solutions. Azure, for example, provides us the quick ability to find out what our costs are for VMs, storage, network capacity, things like that. But when you transition to Kubernetes, things get a little bit cloudy, pun intended. Understanding the costs and efficiencies beyond VMs gets a little more difficult, because you're now slicing up the normal VM into many small workloads that may or may not be the same size. So you also need to take into account your third-party applications, things like for logging, APM metrics, software delivery. All of these subscriptions will add up over time. You can be sure of it. It is a challenge to balance, though, if you should build or buy these things when you think about logs, APM metrics, or any other third-party services. You definitely want to take into account the engineering costs between build and buy, but don't also forget about the cost to operate it after you build it. Many organizations forget to understand that and calculate that when they're building something. I do want to share a little bit with you about how Relativity operates in the cloud. Right now, we operate 17 clusters in 10 Azure regions in our public cloud, and we are also operating in Azure GovCloud. These clusters are designed to scale up into very large clusters using very large instances, instead of managing many smaller instances with different use cases. This allows us a much easier management plane to manage handling updates, software rollouts, high availability, things like that. While I can't share with you the exact cost of what we spend, an idea of how big our operating footprint in Azure, our two largest cost centers in Azure, as we operate around 4,000 VMs in production globally today. And we're expecting to be managing around 8 petabytes of data for our customers by the end of 2020. Let's talk a little bit more about the approaches on how we deploy and manage Kubernetes. There are typically two different approaches most companies will take. You can either take the approach of every engineering team can operate their own cluster using their own processes, and this can lead to a fragmented approach. Everyone has their own ways of deploying images, building images, and also security concerns. This can make it very difficult to collaborate across an organization because everyone's using different standards or speaking a different language. Or you can take an approach which was what we did. We created a standard kind of PaaS offering for Kubernetes for our engineering teams. This unified approach allows us to create an experience that's the same for everyone when we're building images, deploying applications, and of course, our security posture. It also lets us have unified documentation, and everyone is speaking the same language when they're talking about Kubernetes and the clusters. This also leads to a great network effect. So having many engineers knowing how to operate on the same platform across the organization allows us to help scale up so that more engineers as they onboard can seek help from other engineering teams instead of a single small approach. This does, however, require dedicated resources to build this PaaS offering, and it does require you to give it time so we can work ahead to build the platform before our customers internally, the engineering teams, are able to use it properly. So this is a representation kind of how we organize the hierarchy of our applications. So we worked closely with the Relativity, one of our platform teams, so that while our team builds the core Kubernetes infrastructure and all of its supporting applications, we did need to work with our other software engineering teams to create the final step. So allowing engineering teams to quickly and easily onboard into Kubernetes in a unified approach. So this was putting together different frameworks for putting together their applications, deploying their applications, securely building their images, and promoting those images between different container registries. This sounds like a great thing, but it doesn't come without a lot of challenges. Our team spent a better half of a year preparing to be able to allow these teams to move into our PADS offering. It took a lot of engineering effort, and my team worked countless hours trying to create the best experience for other engineering teams. So this kind of gives you a quick idea. So we have our core applications that we manage. We then put application platforms on top of that. So it could be just a RESTful API. It could be another whole application platform like we see here that manages batch jobs or other jobs of some sort. So it gives you an idea of how you can kind of layer your approach when you're developing a Kubernetes platform at a company. So let's talk about the good, the bad, and the ugly of Kubernetes and how we approach things here at Relativity. So I'm not going to focus too much on the good things because most people know what the great things are about Kubernetes. You know, you're allowed to create easily reliable, scalable, and fault-tolerant applications if you know how to use the Kubernetes API properly. A great thing is also if you can leverage a managed Kubernetes instance, this will help you so much. While it may not give you as much flexibility as you think you want, in the end, it's going to give you a much better experience. You'll quickly find if you're not using a managed instance, once you're allowed to kind of turn all those knobs and change all those settings, you're potentially creating an operational nightmare for your other teams in the future because you've got such a bespoke setup. So it's much better, in my opinion, to leverage a managed instance whenever you can. Here are a few of the bad things we've run into through our experience with Kubernetes. Everything seems great when you deploy your first application into Kubernetes. It can be a joyous moment. Then you have your first incident. It hits you and you need to consider a whole bunch of things to figure this out. You know, you need to start worrying about, like, how am I monitoring things? How am I receiving alerts? What kind of metrics am I getting? You're also going to be managing a torrent of logs from all of your containers. So how do you handle that? How do you make sure you keep what you want and realize what you don't? Going down this rabbit hole is when you start thinking more about security. Security is really important for Kubernetes because you can do a lot of different things in Kubernetes. So you need to start thinking about your ingress security, network isolation, intrusion detection, container hardening. The list goes on. But all of these do have ways of solving. There are ways of solving these problems. Another challenge is keeping Kubernetes up to date. Kubernetes is on an average on a 3-month cycle for releases. So they release fairly often, and you do want to make sure to keep up to date, not only for new features, which are great, but also more importantly, security patches. If you're on a managed Kubernetes instance, it's a much easier experience, but it's not foolproof. It doesn't come without risks and challenges. So you need to definitely worry about having a process in place to manage these updates, depending on what kind of application workloads you're managing. For us, we ran into some challenges because we have some workloads that are very long batch processes, and that can be challenging when we need to upgrade things. I'll go into that a little bit more later. Also, some other supporting applications if you can run on top of Kubernetes, like Istio or Prometheus. These also receive regular release cycles, updates. So how do you manage keeping these all up to date? You need to figure out a good process and cadence to keep up to date with these while also not putting an immense amount of burden on your engineering teams. This is a challenge that you're always going to continue to have, but you just need to think about it proactively and know that it is going to happen. So try to establish those processes early. Some of the ugly things about the Kubernetes ecosystem is learning Kubernetes is sometimes I refer to as a learning cliff. It's difficult to get started. There's a lot of information out there. It can be a little difficult to parse all of it. But once you get to the top of it, it starts to become much easier. So while growth is really explosive in the cloud native ecosystem, which is a hot new buzzword, it doesn't come without a lot of problems. There's a lot of lack of engineering experience. There's not enough talent out there right now with Kubernetes. Everyone wants to get in that space, but you'll quickly find if you're trying to hire for it, it can be a little bit difficult. So you need to prepare to train your existing engineering teams and teach them and get them prepared to work on Kubernetes. And that's actually what we ended up doing at Relativity. So a few of us with a minor amount of experience started digging in, learning more, And we worked with our team to basically get everyone up to speed, get everyone feeling comfortable with Kubernetes. Something that you have to realize is things will go sideways. They will. You're going to need to have great SOPs in place and engineers that can find that needle in the haystack to address issues immediately. At Relativity, what we've kind of taken the approach of is we usually try to pair up engineers when we have incidents so that both can share their knowledge with each other and also learn from their challenge. My team actually calls it Collab Lab, funny enough. And we work on these issues together and try to find a solution, and then we document those solutions either as SOPs or just keep it as team knowledge. So we have had a lot of success doing that, where our engineering teams, like the team I'm on, for example, everyone is very, very great with Kubernetes now, very comfortable, and we're able to move much faster, solve problems quicker, and innovate even better. So we'll move on from here. So next thing I want to talk about is what was our first primary workload like when we started with Kubernetes? Our first workload was actually the most intensive compute workload that we have right now in our Kubernetes clusters, which is our analytics platform and Relativity. It has a mix of long-running jobs that are processing millions of documents at a time, and we also have long-running indexes that will sit there and keep a lot of these analytics workloads in memory so that they can quickly be retrieved by the rest of our application. The problem is some of these jobs, they can't be resumed, and they can sometimes take upwards of a day in our most extreme periods to process them. This gives us a challenge with operationally when we need to do Kubernetes upgrades or keeping our nodes up to date for patches. So it was a big challenge, but it was also a great challenge for us to approach initially. To give you an idea also, for our Kubernetes clusters, we do operate several different classes of node pools to accommodate these different compute needs. We operate anywhere from 16 cores to 64 cores on average. And in memory, we operate anywhere from 64 gigs of memory to 400 gigs of memory per node. So we've taken the approach of much larger nodes to handle our different compute workloads to make sure we have kind of a common compute platform for everyone. So what does an average tenant cost us with Relativity in Kubernetes? Well, identifying this in our non-Kubernetes infrastructure is fairly straightforward when we're using the Azure billing system, where we can more or less just kind of get a rundown of how many VMs a tenant might use, how much storage, things like that. Fairly easy. It gets a little more difficult when you're trying to calculate that in Kubernetes because you have jobs that might run on one specific type of node an hour from now, and 2 hours from now it runs on a different node. Identifying how much like a single analytics job costs to execute is possible, but it's a bit complex. You need to know what type of Kubernetes node it's being executed on, how much CPU and memory it's been requested, and how long did the job run for, and how much does Azure charge for that specific compute node that it's using at that time. You can see how this quickly can become a complex problem when we have a lot of these batch workloads, and it is a complex problem. So we had some plans on how we're going to approach this. Originally, our plan was we needed to build a solution. We need to calculate basically calculate and get all this different data. We needed to identify which data sources will provide us the most accurate picture of our costs, and what's the best way to integrate with the Azure billing API to kind of marry the data together. Unfortunately, that we weren't able to find a great open source project out there that could help us solve this. We would have loved to use one and probably try to contribute back to the community, but unfortunately we weren't able to find something that checked that box. We did look at a few vendors initially that specialize in cloud cost management, but we couldn't find something that worked for us, ideally based on their billing models. Thankfully though, our friends at Harness did inform us about an interesting product offering that they were going to be releasing soon, and Ravi will talk a little bit more about that later. We did also estimate though, when we were going to decide to build this, we estimated around one engineer would take 12 months. Now we estimate that in that way because it's just a much easier method of estimating to figure out what it's going to cost the business to actually do that. So obviously a lot of this work could be parallelized among many engineers, but it was a good idea for us an easier way for us to figure out how much it would cost. And this was just for an MVP, just because the sheer amount of data we would need to process and understand and integrate with other systems. So with that, I'm going to send it back to Robbie here for a moment. He's going to give you some information.
Yeah, thanks, Corey. And very, very timely too, I think, just listening to Relativity's Kubernetes journey. Guess I'll be presenting that. Let me present.
Oh, sorry. Yep. Probably should have held on to that.
Oh, no worries. I got you. Yeah, very, very timely too for Relativity's Kubernetes journey. What really impresses me, it's the learning by teaching model, right? So the learner method that usually, if you look at how Kubernetes adoption different organizations, it's a small group of people learning and then teaching everybody. But one of the things that Corey brings up that they don't teach you, even though if you're an experienced engineer, like myself, also I don't have an MBA or nor do I have a finance background, but I know how much stuff tends to cost. There seems to be a disconnect, and kind of one of the core problems to solve is that the consumers, us being engineering team or developers, we're really separated from the bill, right, by a couple layers. So as an end engineer or a software engineer, I'm separated from the consumption by an operations team. And then even they're separated from the final bill by a finance team. So it could be anybody's guess, right? So what's different about leveraging the public cloud is that not only are you having the ability to elastically spin up resources, these resources aren't free. There's multiple dimensions to what cost is. It can be from the control plane, it can be from the compute, the storage, the network transfer, and everything in between. There's no such thing as a free lunch. And it's very hard as a developer, and especially since we change teams, right? So we're not on the same team for like 30 years. So we kind of go team to team or firm to firm, that if we were to build something, how do we know what our workload actually cost us as it manifests into the public cloud, as it manifests on the Kubernetes cluster, and how do we tie that back? And so we at Harness, we've been trying to solve this problem for a while. It's very funny. Our CFO would get a huge bill from one or multiple of our cloud providers, and then he would go to the CTO, and then the CTO would kind of work his way down to the different VPs and different team leads and say, why is this stuff costing us so much? And this is where we introduce continuous efficiency. So we have the ability to correlate your cloud cost with an application. And this is something that Corey is going to show in a minute, that this whole needle in the haystack problem, how do we pinpoint a specific application on a piece of infrastructure? Well, without continuous efficiency, that would require lots of tagging, right? So as an engineer, if a lot of times if you're building something new, well, maybe you might have tag discipline, but if you're coming in the middle, like most of us are, it's anybody's guess. Why is this pod in this application using this much resources? When I do a demo on a Kubernetes deployment, I'll kind of show that there's some easy ways that cost can kind of be overrun. But with that, stay tuned for how you can help pinpoint cost, how you can help identify cost. And all of this is pretty much hourly or almost instantaneous, that instead of waiting for a 30-day cycle to get a bill, which is I have some personal stories. I actually run our AWS account for our training department, and I don't know how much we spend until I get a push alert on my cell phone from my American Express account. As asinine as that sounds, that's kind of the experience that lots of us have. So Corey, I'll pass it right back to you with some of the findings, some of the investigations Relativity made with the product. So I'll change control to you one last time. There you go. Coming your way.
Thank you, Robbie. So as he said, we did start using Harness's continuous efficiency product, and we saw an initial significant drop in our costs within the first 30 days of using Harness continuous efficiency. Our engineering teams continue to iterate on configurations, though, to increase our efficiency based on the metrics that we're getting today. We're also setting budgets now and getting weekly email reports that will continue to encourage our engineering teams to increase their efficiency, to reduce our costs, and continue forward. We do expect Harness CE to help with our costs and get them under control in the long term, but also as we onboard new significant workloads for the rest of 2020 and into 2021. We're also looking forward to a lot of the future enhancements with Harness continuous efficiency that will allow us to integrate some of our data into existing reporting systems that are executive team is currently reading. So I believe actually this might have been another one for you here.
Oh, I can talk through this. Yeah, so
Yeah.
I was gonna talk through this on the demo. Is that one of the challenges it is actually cluster right sizing. And so kind of I'll play platform engineer. So when we're building a workload and something Corey's team has to deal with, and most of the teams ironically I've been on Mike for we have to deal with, is that it's Kubernetes as a resource manager and orchestrator. It will try to fulfill the work requests or resource requests as quick as possible. So as a software engineer, I've been trained to assume that if I request a resource in container size, let's say that I need 2 gigabytes of memory, or let's say I need 4 gigabytes of memory, as a software engineer for safety sakes, I will ensure that I can expect that 100% of the resources will be used when I go to deploy. Now, that might not be the case, and I'll actually show that one of the problems I was running into when running workloads at Harness University is that we were like something to order of magnitude of 15x over. In this example, that's a little bit more muted, but having the ability to look at how to right sizing the cluster helps, and also looking at this particular where the after right sizing something, you can immediately see that the costs go down, right? So having an assumption that 100% of your particular infrastructure is being utilized might be a false assumption. It's something that I had to retrain myself on after years of doing this. It was a little bit difficult for myself, but again, the savings are real.
Okay. So today we're currently using Harness Continuous Efficiency in all of our public cloud Kubernetes clusters. All of our engineering teams have access to see these costs and understand how much their workloads are costing us today. And the best thing is the engineering teams are actually looking at this. They are intrigued by it. They want to get a better handle on it and reduce our overall costs. Previously, engineering teams in our non-Kubernetes deployments didn't have a lot of insight into the costs of their workloads and what it really costs for Relativity to operate in the cloud. Now that they do, and they're proactively doing this, will overall help drive this new change to reduce our costs, increase our efficiency, while still providing a great experience to our end customers. Another great thing is our product managers are working to establish budgets with our engineering teams and forecasts based on the data that Harness Continuous Efficiency is giving us today. So over the next 12 months, we will continue to be migrating more of our core applications into Kubernetes and also using Windows containers. For some of you that don't know, Windows containers are kind of a new thing with Kubernetes. They've only been around for about a year, and even then you could use it in a beta process beforehand, but it's been quite an ordeal. So we have been actually operating hybrid clusters for Linux and Windows since the day one that they were available in Azure. We're currently leveraging a lot of open source platforms to we'll be federating our metrics globally into kind of a single pane of glass for our engineering teams and operations teams, so that we can get all the metrics that we're collecting from all these different clusters into one place. So it's very easy, it's very quick for our engineering teams to make impactful changes. We also are now building our own Kubernetes operators. So we have decided to start building those when we need a lot of custom functionality that may not be offered by an open source project or something that might be specific to our business needs. So we've been leveraging that to abstract a lot of complex operations and processes in Kubernetes away from engineering teams to give them a very simple API to use to either deploy things or change configurations. We're also going to be building tooling to manage our Kubernetes upgrades in a much more automated process. While Azure will upgrade your Kubernetes clusters for you, we have very specific business needs based around our workloads. So we're going to be building an application to kind of manage that in a much more abstract way. And we expect to find more enhancements and ways that we can increase developer efficiency, cost efficiency, and reduce operational overhead over the next year. So I would probably say some of the 3 takeaways with the whole experience with Kubernetes is don't be afraid to take risks. You're going to run into challenges along the way. You do want to learn from them. Measure as much as possible. Making data-driven decisions is a key to success, not only as an engineer, but also for a business. You need to be able to tie metrics directly to business value And that's a really good thing to do. So just measure everything as you can. And also always continue to innovate, continue to push those boundaries. It's a great ecosystem out there. There's a lot of room for improvement and also new ideas. So continue to push towards those things. So now I'm going to go ahead and give it back to Robbie, and he's going to take you through a demo of continuous efficiency.
Oh, thanks, Corey. There's a lot of names on that sharing panel. We can promote it.
Yeah, okay. There you go.
We can promote an attendee like surprise. Perfect. So let's take a look at continuous efficiency. Let's take a quick look at the demo here. So one of the hardest things to do is actually finding that needle in the haystack. So going back to, usually there's a disconnect between the consumers, the app dev team or software engineering team, with one step away from the operations or platform engineering team, which might actually know the true cost coming from the finance team or the FinOps team or the cloud building team, depending on your organization. And so at Harness, since we're a system of record, right, since we have a great idea, so for those of you who are not familiar with Harness, we're a continuous delivery as a service product. So we're actually doing the deployments. And so we're kind of a natural spot that since we know where the deployments are going, we have a great level of certainty because we are the mechanism deploying it. We can also correlate that with your actual cost. And so let's actually walk through a few scenarios here with continuous efficiency. So when you log into the Harness platform at app.harness.io, you can immediately go to the continuous efficiency portion of the product. And actually here, we can take a look at some cloud costs. So we can take a look at our total bill that we have here, actually our per cluster costs that we have. And we can take a look at how our costs are being broken down. I'll actually get into this in a few minutes, but by taking a look at how our actual, let's say Kubernetes costs are being broken down, it's funny that what you're paying for in Kubernetes land is that you're paying for not only the control plane, but the data transfer, the storage, the networking, and also the memory and the compute. Is that let's take a look at how these pressures are actually measured. So going back to earlier in the conversation, I was trained as an engineer that to assume 100% of cluster resources, 100% of container resources would be utilized as a safety mechanism when I place my workload. Well, that's actually not the case, right? Like usually, if you declare something to take up 4 gigabytes of memory, if your application is not automatically taking up 4 gigabytes of memory, right? If it's a Java application, if you set the heap size, it will continue to grow until one of the resource limits are hit, and then Kubernetes, the container manager, will take some sort of action to throttle your resources, let that be an out-of-memory killer or CPU throttling. But how do you actually measure that? One thing that I had a hard time measuring, minus using cube metrics, which we had another conversation, I'll show you how to use that, is that what are these particular costs? The utilized cost is actually what you're actually consuming. The idle costs are actually, this is the one that I had a hard time measuring the most was, given a certain pod, if I declare I need X amount of resources in a resource request, the difference between the actual and the request, right? And I'll show you what that looks like. And then the worst one would be the unallocated cost, right? And so as we know that Kubernetes is in a worker type of model, so your worker nodes, they're actually where your work gets placed. But for those worker nodes, they're only a certain size. The unallocated cost is one way that scaling your workloads can be problematic. I know Corey and I can bore you to death about right-sizing your cluster around, for example, let's say if you had a 16 gigabyte cluster and your particular 16 gigabyte memory in a particular working node and your machine type, that you have an 8 gigabyte, let's say, a particular request for resources. The irony of that is only one of those particular pods will get placed because, again, the operating system at Kubernetes has overhead, and this will allow you to see that you have a very high unallocated cost. But we'll look into that in a second. Also, the Harness product will actually help score it for you. So there's a blend of model. There's some division going on between your utilization and unallocated cost. We can actually tell you how healthy you are. And also, if you're exceeding a budget, right? So we'll take a look at this in a quick second, that if, let's say that your forecast, the amazing thing about the product, we can actually help forecast your cost also. So if your actual cost or your forecasted cost is going over, we can actually take a look at that. We help break down cluster cost and also cloud cost by day. And here's where some of the real kickers are. We actually help break it down per application. So let's say I was the one in my fictitious Harness demo application here. How do you know that the Harness demo application is only spending X amount per deployment? How do you know versus the rest of the services versus the rest of the total cloud spend? And this is what we can dig into in the Harness product. And so if we take a look at, one of the first dimensions we can look at, let's take a look at the cluster metrics. So this is a very Kubernetes cluster or ECS cluster look. If we take a look at a certain workload, for example, let's say I have my Harness demo in Google Kubernetes engine here. What is the actual cost of this particular workload, right, or this particular deployment? We can take a look at certain particular costs that we do have here in our particular deployment. What are the actuals here? And this is the hard thing to for me to look and metric over time in running Harness University. So there's two types of resource requests that you have in Kubernetes land. So there's the limit and the request. So the request is, dear Mr. and Mrs. Kubernetes, I need X amount of CPU, I need X amount of gigabytes of memory, and that's guaranteed by the orchestrator. Also, there's a limit if we touch above a certain threshold. Let's say that the limit's usually a little bit lower than requested to make sure that you're not touching the end there. But here, look at the actuals versus what is requested, right? Or the memory is even a better one. Like, look at what we actually are leveraging versus what we're actually using. And this is pretty amazing that we can see that, hey, I'm an order of magnitude of 2 or 3 over in our particular workloads. And this is something that we can help reduce the cost to. Now, given the cost is not very expensive here, but you can imagine if we extrapolate this over dozens of pods. And also with the Harness application, since we're a system of record, we can actually keep track of the deployments. And so, for example, here we have deployments that are going on every day. We can actually take a look at, hey, this deployment that somebody made on the 19th of July, there were some changes that were made. So if this had some sort of inverse effect on the cost, we can actually see how that would impact the actual cost. Similarly, we're able to track down what I think is very interesting, the actual cost of the application. And so not only are we able to look at, hey, this is the cloud cost spend, we're also able to look at, hey, you know what, Ravi, you're running this demo application. It's costing us $3.40. So these are actually, it's funny, these are the actual costs to us, giving people demonstrations of the Harness product, right? So we can even take a look per service, how the cost breakdown. And again, given that, if we can find an application, if you're looking at, hey, how do we start reducing spend, figuring out who the most infracting application is very important. It's coming back and taking a quick look at a budget really quickly. Now, we can actually set budgets. For example, if your spend was hitting a certain limit, not only is it interesting to know that with particular budgets that what your actual spend is, getting alert, you can actually show what forecasted spend is, which I think is pretty interesting. So we can set alerts on, let's say that we have a particular spend of budget. We could also say that, hey, if we're getting closer to a specific amount that's in the future, let's go ahead and alert with us. We can actually see what forecasted spend looks like in the product pretty easily. So we can actually select dates that are in the future. So instead of last 7 days, let's jump forward to the next week ahead of us, and we can actually look at some forecasted spend that we do have. Lastly, in the particular product, we can also take a look at, the actual spends that we have here. Taking a look at our total spend that we do have. So again, if some resource is not managed by a continuous efficiency, we can actually show that this is what your total cloud bill would be. Flipping back to the presentation now. Now, if this was interesting to you, we would love to get in contact with you with Harness. We actually have a t-shirt store that we do have. So if you go to harness.io/t-shirts, if you would like to learn more about the continuous efficiency, sign up for a demo. We can send you one of these great t-shirts. I think Corey has several of them. He actually has more than I do t-shirt wise. Would love to send you a t-shirt to learn more about the product. And with that, we can open it up for questions and answers, or for some questions if folks online have questions for us.
Well, we'll have the questions. You guys have the answers. How's that?
Sounds fair.
All right, great. So yeah, there's plenty of time for questions, guys. If you do have one, please go ahead and use your GoToWebinar control panel and submit your question. Let's see what we've got in so far. All right, here's one for you. Hi, does Relativity build their managed Kubernetes cluster on Azure AKS, or do they benefit from Kubernetes managed platform like D2IQ, Kubler, WeaveCloud, Kubernetes?
Great question. So we actually leverage Azure Kubernetes service from Azure. the reason behind that and not using another process for that is mainly because we have the requirement of we manage both Linux and Windows nodes, which there are tools out there that can do that. We also have another requirement that because we operate in GovCloud, we need to be FedRAMP compliant. So AKS is already has FedRAMP authorization for FedRAMP moderate.
All right, great. Let's see, here's another one for you, Corey. When did you notice that your Kubernetes spend and clusters were growing beyond what was normal? We're kind of reaching that point now.
I mean, there's not really ever a normal because we have, our compute scales up and down quite a bit. I did notice though from the beginning that this was going to be an issue because of the nature of how our company currently looks at billing for our cloud costs, and realizing that method won't work for Kubernetes because it will look just very opaque. And we want to understand how much our individual workloads cost. So that's why we ended up looking for a better solution.
All right. Guys, if you have a question for Corey or for Ravi, please go ahead and use your GoToWebinar control panel and submit it. We've got plenty of time for questions.
Don't be shy.
Let's see. Don't be shy. They're here to help. They're here to help. So, okay, so here's another one for you, Corey. Did you try any other products or approaches?
If this is in reference to cloud cost management, we did look at one individual open source project. I don't remember the exact name off the top of my head because it was a while ago. And we looked at a couple other vendors that work specifically with cloud cost management, and that's their only product offering. Continuous efficiency from Harness ended up being a more logical choice for us because we already leverage their continuous delivery platform. So it just made sense, especially when we were working with them early in their development process to understand how the product could benefit us.
Excellent. Okay, I've got one more question here, and then, oh wait, no, we got another one that just came in. Let's see, how tough is it to establish a Kubernetes cluster on premises without any of the cloud PaaS offerings like AKS or EKS?
I can take that, or you can take that, Corey. So
go ahead, Ravi.
Yeah, so I mean, there's like the quintessential model for that is like Kelsey Hightower's Kubernetes the hard way. It goes about installing Kubernetes with like zero help. A lot of times now, like there's ways to like, I take it for granted of it. Like I'm used to not installing Kubernetes by hand. So it depends on like how big of a cluster you want, right? Like if it's just installing it locally, like Minikube, it's fine. But it sounds like the particular instance of size might be something more substantial for your organization. Maybe it's a disconnected environment. So it can be a challenge, right? Because again, a lot of the Kubernetes, let's say dependencies and projects, they live online. So like sneaker getting that into something that's disconnected, I'm assuming it's disconnected. If you're asking for that level of granularity, might still require working with the vendor at some point if it's not too difficult. But again, it's, there's someone had to make it at some point. But I'm used to doing it with more help. Corey, I'm not sure if your experience is any similar or different than that.
When we initially were approaching Kubernetes, we were hand building clusters before AKS supported the features we needed. So I do have experience with it. It's not a recommended approach unless you have a significant operations team that's going to be there to monitor and operate a lot of the underlying components of Kubernetes.
All right, great. Let's see, gotten a couple more in here. Let's see. How much percentage cost deduct to using Harness? I think what he's trying to ask is how much cheaper, or what on a percentage level, how much is it cheaper to use Harness?
Or maybe the cost savings percent-wise, if you can say it.
Yeah, exactly.
I mean, if they're referring to cost efficiency, like compared to a different vendor, we never got to the negotiation stage for the other vendors because of when Harness showed us this product. It became really clear that it would work very well for us with our existing contract with them, and just because it seamlessly works with a continuous delivery product. So we didn't really get to a point of comparing the pricing structure between them. However, most of the other vendors we've seen out there do their pricing based on your overall cloud spend. And if we were already going to be partnered with someone, we prefer to continue to work with a company that we already have a good relationship with.
Okay.
Or I think that question might be like, was it worth your while? Like the amount of money saved?
Yes.
Like, yeah, like definitely.
Money
Yes.
saved.
Yeah.
All right, great. Here's another one. Let's see, Azure Unix-like containers running as WSL2 on Windows hypervisor. How would it perform a cost comparison on a container versus real Linux on top of Azure?
Could you repeat that one more time?
Sure. Azure Unix-like container is running as WSL2 on Windows hypervisor. How would we perform a cost comparison on containers versus real Linux on top of Azure?
So like Windows subsystem. So I'll work. Corey and I can work this one together. Corey, don't feel.
Okay.
Yeah.
I heard some words there. So it's like the cost of running a workload on Windows subsystem for Linux versus running it on a pure Linux machine. I never got that question before. I mean, we can take a very generic stance to it. Like there will be more overhead in WSL because you have a Windows machine and a Linux instance running at the same time. So you technically have two operating systems that are running in parallel.
Right.
I would say
Yeah, you're also going to lose performance with that just because of the translation for WSL. Now WSL2 does use a separate VM that's designed for that. If you're more referring to like how you handle Windows in Kubernetes, Kubernetes nodes that run Windows containers have to be Windows host nodes, and they don't use WSL2. So that lowers the overhead for costs, but Hyper-V is also not currently supported within Kubernetes.
All right, great. Let's see. Okay, here's another one for you. How do we set up a CI model like Jenkins master slave architecture in an EKS cluster? Is it recommended to integrate Jenkins with Kubernetes?
So I think you absolutely could do that. Relatively, we do run a pretty significant Jenkins infrastructure for some of our CI and build processes, and we've absolutely started looking at moving our Jenkins operation into Kubernetes as workers. So it absolutely can work. There are a few plugins out there. I believe Jenkins has just a straight Kubernetes plugin. There also is a project called Jenkins X that is designed more towards running Jenkins solely on Kubernetes. So it definitely, Kubernetes is a very good candidate for Jenkins. It's for the case of all of the different worker nodes and your master nodes. It does work. The model works very well. You just have to work through all the technical challenges.
Yeah, and I'll take a stab at that question too, because I have opinion on that. So I think pretty much for my engineering career, like I think it's kind of par for the course for over a decade that we had distributed Jenkins executors on the teams that I've been on, but they're always managed differently. Like take it 10 years ago, we were spinning it up manually versus like come around 2013, 14, 15, where we're leveraging like a PaaS like PCF or OpenShift to kind of spin that stuff up. And then more so today, like because of like the ubiquity of Kubernetes, like we're using Jenkins X, right? Like it's the quintessential DevOps bottleneck used to be your build. Because, for example, if we're building Java, we're building megabytes, but then introduce Docker to the mix, your 6 megabyte Java application is 3.7 gigabytes in a Docker image. You're like, what? Why is all this there? Right? But that takes a lot of horsepower. Like the amount of horsepower it takes to build something is a lot. So that's why you're seeing a lot of distribution in the build that you're doing. So pick your poison. Kubernetes is an excellent resource manager. It's an excellent orchestrator. If you had ephemeral builds, it's a great platform to spin up pods for you to do your build in there. So but most of the CI tools, like modern CI tools like Jenkins X, like Concourse Drone, et cetera, like they play really well into those models.
Excellent. Okay. All right, moving rapidly along. Guys, there's still plenty of time for questions. So if you have one, just go ahead and use the GoToWebinar control panel. Easy for me to say.
Keep them coming.
Yeah. Keep them coming, absolutely. So here's another good one for you. Do you use disaster recovery for Kubernetes clusters?
Yes, we do. So we, just as part of our business continuity process, we do work on disaster recovery. We have a lot of processes and SOPs in place. The way we handle Kubernetes clusters is we think of them as cattle, not pets. So we have our entire deployment model is designed that we can completely destroy a cluster and re-provision one and have it ready to go to deploy our applications in a very automated process. Mainly for the fact that we don't want all of these snowflake configurations everywhere. We want to be able to have it repeatable in the case of disaster recovery. So right now, we do practice that once a year for basic for our compliance, but I would definitely recommend practicing the idea of cattle, not pets.
I also like this question. It really depends. Like I give the depends answer. Like it depends on what your definition of disaster would be, right? So like when I'm dealing with like, let's say like clients in my consulting career like years ago, like it would be, are you talking about smoldering earth? Their data center got hit by a meteor. Did it catch on fire like AWS's US East? I used to live in Northern Virginia at one point in Sterling, Virginia. Yeah. So like, what is your definition of a disaster, right? And what is your, going back to the Corey's point of like business continuity, like what are your key metrics for like restarting the business, right? So like in Kubernetes architecture, you can kind of architect around that. Now, if you're, for example, you can have multiple masters in Kubernetes, right? But is it a warm replica? Is it a hot replica? How quickly does it need to take over? And also, it's very workload dependent. Certain workloads you can reconstitute quickly, but some stateless app, sure, like let's change the load balancer and spin up another Kubernetes. Like let's change the masters or spin up another cluster and like replicate into another cluster. Versus if it's a stateful workload, we might be not using Kubernetes for 100% of that workload. For example, let's say there's some sort of long running task, you might have like what we call off Kubernetes workloads that it might represent a share of it, but also for disaster recovery, for clustering, for HA, we're actually good distributed system principles still apply, right? So it's as diagnose the patient, understand what the amount of, just like a business continuity term was like slipping my head, like a core metric that you have to look at. Like it's not MTTR, but it's something else that to get the business up and running again and then work your way backwards for that.
Excellent. All right. Yeah, so many great questions here. Okay, here's another one. Let's see. Using continuous efficiency, what are some effective approaches to ensure development teams are proactively managing costs? Ravi, I don't think you should actually answer this one based on your American Express bill. In my experience, there may need to be additional guardrails that accompany the data. I'm kidding. You can answer it.
Oh, I got the Corey. Yeah, like it's funny. It's all about discipline. So this is like my take on it, right? Like as a ex like dev manager, right? Like it's about team discipline. So as engineers, we don't try to do anything nefarious. Like understanding people are good. Having that on. It's all about information. It's same thing with AppSec. It's same thing with like this like fringe like non-functional requirements. I don't know what I don't know. We can take gambles on like these are like best practices like to be efficient, but you don't know how much something costs. So if I was presented with data that, hey, these workloads are expensive, we would intrinsically take action on it, saying like, okay, now we know where it is. Let's go take action on it. Because again, it's even rewiring my expertise that I assume 100% of the resources are going to be used when it's placed. It's starting to be untrue at this point. So Corey might have more rubber meets the road, like how organizationally you can encourage people, but from a developer standpoint, like give me the data, we will take action on it, if it's a priority.
And I agree with Ravi on that. Like I said in our presentation, is when we're actually giving this data to the engineering teams, we've quickly seen that if they have it, they want to do better. They want to make their applications more efficient. And that it's been a very eye-opening experience in a good way, just because a lot of teams maybe before they just didn't realize how to find our billing data for Azure, or maybe they didn't have access to it. Now we're kind of opening that door and empowering them to take responsibility for it, which is great. And I agree with Ravi. It's like the engineers don't know what they don't know. They're not trying to waste resources and things like that. But this gives them the tool that it's right there in front of them. It's very easy to get an idea of what their costs are and take action on it.
It's the
All
quintessential
right.
carrot versus stick argument, right? So
Yeah.
every organization I've been at is very carrot based, but some people need a stick. So it depends on the organization. So yeah.
Excellent, excellent. Well, we are running up against 5 minutes to the top of the hour, so I think we have time for one more question, then we're going to have to close it out. And let's see, is there an option to provision a Kubernetes cluster in a multi-cloud architecture like what is done with Mongo Atlas?
If this is referring to like a Kubernetes cluster that is the worker nodes are spread around across multiple cloud providers, it's theoretically possible. I have not done it. It sounds really interesting. Most companies take the approach of you would have, you might deploy Kubernetes clusters in Azure, AWS, GCP, and your delivery platform would handle managing the applications for you that way. The idea of a cluster spanning multiple cloud providers from like the lower level, I don't think I've seen that. You could also connect them together through like an Istio mesh, so that you could communicate across different cloud providers with clusters in each provider. There's a couple different approaches there.
Yeah, that's actually very difficult. I know we're coming up on time. It's like I would actually like Corey's saying. I would advise against that because again, like latency will kill you, right? Like each one, like let's say my AWS regions are completely separate from the Azure regions, and so what I've seen people actually attempt to do that. There's a couple ways. Like there's Kube Federation. There's other pieces of the infrastructure that attempt to do that. It's again the fallacy of the distributed computing will come bite you. Latency will get you. Kubernetes will mark the nodes as unhealthy, and it's like it needs constant communication with kubeadm. So like if any sort of hiccup happens, it could be bad news for your workloads. You can have some consistency problems. Again, there's architectures that you can architect around that. There's managers and managers, let it be like a platform as a service or Mesosphere DCOS or Marathon. Like there are ways to accomplish that, but yeah, like straight up wiring worker nodes in different regions, they will be marked unhealthy very quickly, more often than you would think in Kubernetes.
All right. All right, guys. Well, we are 3 minutes to the top of the hour. So unfortunately, that is all the time that we have for question and answer period. If we didn't get to your question, I do apologize, but please know that Ravi and folks at Harness will be getting a copy of all of the questions that come in. So I'm sure either he or somebody from the organization will be more than happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, at the top of the hour, I did note that we would be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and do that now. Let's see, our lucky winners today. First winner is Eric P. Congratulations, Eric. Our second winner today is Hector M. Congratulations, Hector. Our third winner today is Maria C. Congratulations, Maria. And our final winner today is Joe W. Not Robbie. Congratulations, Joe. We'll be following up with all 4 of you offline via email to get your $25 Amazon gift card out to you. So please check your inbox, and if it's not there waiting for you, check your spam folder. I guess that's all we have to say today regarding this webinar. But Ravi and Corey, thank you so much for such a great presentation. Good stuff, lots of great information, and lots of great questions that came in from the audience too. So I know they got a lot out of it as well. So thanks again. Appreciate your time and your expertise.
Cool. Bye, y'all.
Thank
Thanks
you.
for having us.
Great, everyone.
All right, great. Well, I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.